Hey everyone. Thank you for coming to this presentations. So this half an hour, I'm going to talk about becoming a SQL renovation expert. Um, Basically, what you see on the screen when Emily said with a little help from Emily, that's a big lie. So she helped me a lot. So thanks, Emily. Thank you. So this is a little bit cartoon that I did. That relate to the SQL renovation expert. To me, SQL query is about pipeline. How you get your data and then output at the end. So a lot of traffics get stuck in the pipeline, either too big or too small. So before I start, let me talk a little bit about me. I joined the SU Plus Data Analysis in June. So I've been here maybe just 3 months, and I have 2 kids, Joy and Josh. Joy is 14 and Josh 11. And I like graphic. I'm an artist, and also I'm a published author. But believe it or not, even I wrote 3 books, I'm not smarter than 4th grader. Thank you. So the agenda today, I have I'm going to do introductions and then talk about the select star, CTE versus subquery, exist versus in, join conditions, select distinct, and then at the end I'll talk about the SQL format. So SQL to me is the when I first learned about SQL, I kind of like confused about the previous programming language that I learned. But now if people ask me, Helmy, how do I learn SQL? It's very, basically, you got to learn it, but you have to understand the SQL is the declarative language, or known as a non-procedural language. So I put a cartoon right here, like, can I select chicken tacos from a menu A where I don't want onion. So that's very basic SQL. So writing SQL query is not just about building a query blocks, but how do you write it using the best practices? So what is the best practices? So this is one of the good example that Emily gave me the idea, returning shopping cart. I mean, I was a bad person as well before, like when I finished, put all my grocery in my car, I never returned the shopping cart, but I do now. But the question is, if you don't feel bad, because you're not a bad person. You're just not doing the best practices. So 3 orders that I'm going to talk about best practices for writing a SQL statement is like, is our query efficient? Is our query readable? Is our query optimized? Meaning, is that cheap or expensive? So are you ready? Thank you. So first one, select star. Always using select star is not a best practice, and it's really bad for the SQL performance, unless if you can write this SQL select star query. Because select star, it increased the network traffic and increased the CPU usage. So by not limiting the columns, we are actually sending more data and unnecessary using more network and database resources. So this is a best cartoon to describe select star. We don't really need all of them. The second reason why we shouldn't use the select star is less chance to use indexes. So index is primary methodology that we use to increase the performance, right? But as we know, like not all table, all columns has an index. So if we do select star, basically we actually turn off the index, because select star means like, SQL Server or SQL or Redshift will scan all the columns. So here a basic comparison of SQL execution time statistic. Statistic parse info when using actual column names versus select star. So I took this adventures work database just for an example. So using select star is actually just very basic table from that dim customer select star. I'm getting about 46 millisecond CPU time and 555 millisecond elapsed times. So I use the set statistics IO time on just for debugging. If you are SQL Server, you can use this. But since as you use Redshift, I think this syntax won't work. But we do have a explain plan. You can see how much it costs. And this is the comparison using the select all the columns. We're getting less CPU time, 31 millisecond. Elapsed time is 516 milliseconds. Earlier I mentioned about how we see the explain plan in the Redshift. You can go to your SQL editor and then just turn that on, explain execution plan. That will give you how much it costs. Or you can do explain. Explain will give you the detail by rows, like every single blocks, how much it will cost. Select star is very common that we use because it's very handy, right? But I will recommend just to use it when we do a quick search with the limitations. You can do like in SQL, you can do top 5. In Redshift, I think you can do a limit 5 after from table, and you do the limit 5. In Oracle, you can do row columns. Something like this. So this is for the Redshift limit 5. So that's the end of the first session. Any question? All right. So I'm going to move on to the CTE versus SubQuery. CTE is nothing else the common table expressions, that start with the with clause. And this is one of the example that I use CTE using that adventure work database. And SubQuery is nothing else a query within a query. So that's below is the example of the SubQuery. So the question is CTE faster than SubQuery or is CTE better than SubQuery? So I have that SQL Pro going to the SQL sandwich. The guy asked him, would you like to have a CTE or SubQuery? So this always become, pro and cons. Anyone knows which one we should choose between CTE and SubQuery? So the answer is depends. Depends on the cases or scenario. If you will be reusing the codes or result multiple times, CTE are great because they are readable. You have that set, you have blocks, and you can reuse it within a query many times, as many as you want. Like on the right hand side, that's an example of the CTE. It create a readability, and you can reuse it for more than one times in your next query. However, if you use the set of query only once, an embedded subquery might be more efficient. So talking about the CTE and subquery, if you're doing the reporting, right? Let's say SSRS or Power BI Tableau, you might use a data set for your parameters. Then CTE and subquery is not a good idea to have it, because if you create a data set in your SSRS for your parameters, you're just basically doing very simple select from table. Any question? Thank you. That'll make my life easier. All right. So next topic, about exist versus in. Again, in my SQL career, I always ask, SQL expert, like, which one do you like? I like exist better. The other person said, I like in better. So does exist perform much better than in, or in clause faster than exist? If you have coin, you can just flip it and see. The exist clause performs much better than in when the subquery results are very large, so that the exist. The in clause is faster than the exist when the subquery results are very small. So again, it depends on the scenario. There is no true and false questions using exist versus in. So I provided the example using in. Basically, it's like subquery. It's like if you want to search for, let's say, student ID in, for example. This example I used the Adventures Work database, which I said, hey, I want to see my geography key in that select subquery statement. While the exist, basically, it's similar like join. So it's also placed in a where clause. Instead using in, I use the exist, and then I do my subquery. But in my where clause, I have to tie the joining key in that subquery with the outer query set. So that's using the exist. And I provided some differences between exist and in operator. You can kind of like look up on Google. So again, there is no pro and con, true and false question answer about using exist and versus in. Any question? There is none, because again, so this topic is, this topic, Emily and I, we want to kind of like talk about the best practices, and also the renovations, right? Every set has a different scenarios, which is I'm going to talk about that joining for the next session. So there is no, to answer your question. You have to look at the performance, like when I start my query, right? So I mean, if people say, hey, Helmy, you told me that for the large data set I have to use exist. True for most cases, but when I start building my query, I start with a small set. I look at the cost, I look at the efficiency, I look at the table, I look at the joining, I look at the logic, and then go further down, bigger set. So you have to look at different scenarios. But if you just want to do a small set, like for if you build SSRS report, you want to build a data set for your parameter, like select column ABC from table A, where the student ID in, then you can use that in. But when you're talking about a large data set, that's very complex. There's a lot of things going on there. So Emily, do you want to add that?
It's a relative thing. So we said large versus small, but large is in conjunction with the what your other set is you're joining to or you're comparing against. So if your outer set's 1 million records, maybe 100,000 small, or if your outer set's 50 records, your inner set better be about 10. It varies again. There were some other restrictions, the list of differences there. There's cases where exist works better than in for certain situations. But yeah, that size thing is a relative to the full query and to the amount of data you're processing and returning. So hope that helps.
Good question. Thanks, Emily, saving my life. All right, so this is the fun stuff here. Joining conditions, right? This is the most common mistake which I'm going to discuss about the joining. Joining is the very, very primary important things and when we build a query set. In my interview, I challenged the interview. They asked me, tell us about left join, tell us about inner join. I told them, you shouldn't ask me that question. I didn't get a job, by the way. Just kidding. They said, why? Because I can just memorize what is inner join or left join, but you should ask me more complex cases. How do I use the joining by providing me a tables cases? Because a lot of us making a lot of mistake, including me, with this joining condition. So let me see. Anyone knows like what's the most common mistake we could make using the joining? A lot of mistake. That definitely will get fired. Just kidding. Good answer. The answer is the left join or right join, right? You know, like when we do a joining, we have let's say from table A, and then left join table B on the primary key, right? But then we have an extra additional logic that added, like and let's say student ID or grade equal to W withdraw or whatever, like ABC. Like if you put that joining under so let me give you an example first, right? This, let me close this here. Sorry. Yeah. All right. So let me give you the example. First table, this guy right here. It's dim customers, right? We have 10 records. I just doing a filter so we can see a small set. That's how when someone asks me about when I teach someone, I start with a small set, right? That's the first table. 10 rows, only like 5 columns. And this is the second table, right? Which is the dim geography. We have what 200 something, 201 records, right? So I'm going to do a joining with two different joining, right? The first one, I have that second condition. If you look at the and, the geography between 200 and 400. This is the correct best practices because you're doing it at the joining level, which is if you look at the SQL query process order, right? SQL will go from first and join on the top. If you look at the process order, so this is the correct correct format, right? So because you do left join, so you are expecting about 10 records, correct? Because your left join, your hard query is from the dim customer, which has the 10 records. So this is the correct format. This is the most common mistake. I apologize. I cut the last end section, which is I moved that the second condition from that left join. I put it down to the where clause. That turned into an inner join, and that's a misleading the data, right? Because so the second condition, if you do left join, you have to be careful. Make sure you put it on the joining level, because if you do left join or right join, and then you have that second, third condition on the where clause, it's a habit, bad habit. But it's not a good best practices, and also it's a misleading data, right? Only if you do left join or right join. Yeah. Yes. Yeah. That is the best practices as well. Somehow SQL Server has their own plans. As I mentioned earlier, it's non-procedural language. So SQL Server has its own optimized logic. So yeah, to answer your questions, that is correct. So that is the joining condition that I seen a lot of mistake, including I made this a lot of mistake. And in my early career, my manager said, "Helmy, are you doing left join or inner join?" I'm doing left join. Well, you're doing inner. No, left join. Let me prove it to you. So there you go. Any question? Any more question? Easy life. All right. Select this thing here. So Emily is a big help when I doing this draft. Select this thing. I think like when we do select this thing, basically we're trying to remove the duplication, right? And I've seen a lot in my earlier career. A lot of SSRS report subscriptions fail all the time, every week, and I have to tune that query. I've seen a lot of developers like build select this thing in a subquery and then select this thing again and then select this thing again, right? That's too much. I mean, we should avoid the select this thing. I mean, removing duplications can be catch as early as possible, right? Select this thing cause the database servers to scan all the columns, and most columns are not indexed. Select this thing is also equivalent to doing a group by on all columns, which also decrease the query performance. Select this thing does an implicit sort across all the columns and then discard duplicate, which require a lot of extra processing, especially on very large resource sets. So we should avoid using select this thing as much as we can. How? Anyone know? I'm sorry? Yes, that will work, meaning that if you have a query sets, right, you don't need all the columns like so like having a blueprint, a plan how to get your request done in a query, like limit your columns actually will avoid that duplication as well. So you don't have to use this thing. Good answer. Yes, yeah, that's a really like good answer. So understand the tables that we are going to use in our query, right? And understand joining relationship to avoid the duplication. I mean, if you think about this, right? Why you want to use select this thing? I mean, when you start building a query set, right? You have to familiar with the tables. You have to look at the data, right? And if you can catch that as early as possible, like building a clean and unique query set using a CTE, that will help you to get a unique records. Then you don't have to use select this thing. You can use row numbers, right? If you wanna if you wanna see like how many records being repeated for certain columns, you can use row numbers over partition, but you have to do partition by what column you want to kind of like see how many times that being repeated, right? And I have an example in the Redshift where I want to see in my CTE, I want to see how many times the employee ID being repeated on my record set. That comes with the logic for the customers. And this is just an example using select this thing. Oh, by the way, this is a good if you are using SQL query, which is using Redshift. I just thought to add this information. This is in my earlier career that I tune a lot of queries, a lot of reports, subscriptions fail because a lot of this thing. So what I did, I do a row numbers, and I include all the final columns, and then order by the columns. If I have more than one records, that telling me that's duplication. Duplication means like from column 1 to column Z, you have the same values. And then on my where clause, I use the, you can alias that a row num as like get this thing equal to 1. So from 24 hours query timeout to like 10 minutes running. So if you use SQL query, I'm sorry, go ahead. I try to avoid having, they're expensive. Yes. Because if you look at the SQL process order, having is falls under, I think, number 5 or 6 after the where clause. So having is like a lot of, it's expensive. Let's see. And this is using the unique row numbers, using every columns by order by. So that's kind of like the extra informations. Any questions? All right, almost done. The last one is the SQL formatting, right? I mean, our team's heading to the source control, right? Peer review. I think everyone has different style. Like my style and Emily's style is different, right? I tends to have uppercase when I do select from. I cannot stand if I see lowercase select from. This is just me. I have to change it. So using the SQL format help me to see if I have to do an update. So I provide 2 website. I like this one, pureSQL.com. You can eliminate you like uppercase or not, like me. You can use PureSQL, and you can do SQLFormat.com, also another good one. I think it's good to have a format because session here, and we want to make sure when we write something, it's not for us. It's for somebody else to read, right? We want to make sure we can provide a clean, readable efficiency. Having a format also will help you to catch the efficiency. So Emily add a few stuff here to in the Redshift debufer. We can set the format as well. So if you don't like that SQL, pure SQL, I don't know why they call it pure SQL. And so that's the end of the presentation. I hope Emily and we can help you to renovate your existing query, or try to use the best practice when you write a query. So thank you.